This is the sky. I know what you're saying. You're saying, well, there's nothing there. What do you mean there's nothing there? There's enough to fly on. Want to see it again? Things fly. Pretty cool, huh?
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy. Brought to you by Air. Without air, you ain't flying.
Air pressure makes things fly. That's it. From June bugs to giant jets, they all fly because of air pressure. And you're saying, well, how can air make that much pressure? I mean, it's not like it has a test tomorrow or anything. And besides, air is so light and, well, airy. But it's air pressure that lets us breathe. And it's air pressure that makes the wind blow. Without air pressure, nothing could fly. Take a look at this. It's our plastic airplane of science. This airplane is flying, even though it may not be going anywhere. Maybe you know the feeling. Anyway, air moving over the wings is creating what scientists call, maybe a scientist like you calls, lift. Now, it's like when you lift something up, like maybe when you lift up a 400-ton jumbo jet or a plastic airplane of science. Now, where does the lift come from? Well, it comes from moving air. When the wings are tipped up a little bit, the moving air creates differences in air pressure. Air pressure! The air going underneath the wings is going a little more slowly than the air going over the top. Now, when air is moving this way, it pushes this way. It doesn't push so much up or down. So there's a little higher pressure under the wing than on top. And that difference in air pressure creates lift. Now, this thing that happens with air, that when it's moving this way, it pushes this way and not so much sideways, is named after a Swiss guy named Bernoulli.
Yeah.
So we call it the Bernoulli effect.
The Bernoulli Effect.
When the wing's curved on top, it doesn't need to be tipped up as much to get lift. It doesn't need as big of an angle of attack. Whew. Airplanes fly because their wings develop differences in air pressure when they're curved on top or given an angle of attack. So, airplanes are held up by something we can't see. Invisible air pressure. Huh? Not that bad, not that bad. When we throw the plastic airplane of science, differences in air pressure created on the wing develop lift. Huh? Lift is what makes flying discs fly, and kites. Check this out. Ordinary balloon. Now, some of the air we breathe, the air that's around us all the time, is now inside the balloon. I've used the power of my lungs to force molecules into the balloon. The more molecules in the balloon bouncing around, the greater the pressure, and that pressure causes the balloon to expand. Air pressure. Godzilla. Daisies. This one? Well, we're gonna have to work on that. See, air pressure gives these balloons their shape. Without air pressure, we'd have something like this. Although watching balloons fly around, not that bad.
Here's another experiment you can do that shows what air pressure can do.
Get 2 pencils and a nice big balloon like this.
Now get a heavy book.
You can use a balloon to lift the book.
You can do it with air pressure.
Set 2 pencils on a table like this.
Place the balloon between the pencils with the open end of the balloon hanging over the edge. Now, put the book on the pencils.
Just blow into the balloon.
You're lifting the book with air pressure from your breath.
Phew. Check it out. Power pack puffs of air. Air pressure and science. They're powerful. Science rules!
Yeah, it's a pretty good day for parasailing. Ah, that was great. Anyway, here's the parachute. This is the front, and this is the back. Between there, we get high pressure. So on top, we get slightly lower pressure. And that difference in air pressure, that's where the lift comes from. That's a Boeing 727, a classic jetliner. It's full of people, kids, dogs, and choice of chicken or beef. It weighs almost 100 tons. 100 tons! That's a lot of tons to get off the ground. How do we do it? Differences in air pressure. Even though we all know there's thousands of airplanes taking off and landing every day, it's still a pretty cool thing to watch. Wish we could see that again on instant replay.
We can, Bill. Bill,
Oh, hey, I didn't know you guys are up there. Go ahead, rewind it.
give me camera 1. No, 2. No, 3.
That's great. Okay, now check out the airplane's wing. Look at its shape there. That's important because as the plane gets going, some of the air is going to go over the wing and some of the air is going to go under it, just like the plastic plane of science. Back to you in the booth.
The X's are going over the top, fast, and the O's are going underneath, not quite as fast.
Ready to? Take 2. It's the same air, just traveling at different speeds, which creates a difference in air pressure.
The faster X's can't push down as hard as the slower O's push up. The O's push the wing up.
When the plane gets going, the air on top zips right over the wing, which creates an area of low pressure.
So, you've got high pressure underneath and low pressure on top to create lift. The X's and O's get back together at the back of the wing. Ready for Bill? Take Bill.
With air moving over wings, we can develop differences in air pressure that can be used to create lift. Now, how do you think we get air moving? With engines, big engines. That's how we get air moving. Now, let's keep the show moving.
This is the simulator room, and the one we're going to fly in today is the 767-200, so we'll go ahead and walk on in. Hi, my name is Susanna Darcy, and I'm a test pilot for the Boeing Company, and I'm rated to fly as captain on the Boeing 737, the 57, the 67, and 747-400. And this is a simulator that's used for doing all the training for airline pilots and test pilots that are getting their ratings on the 767. Pulling back right here. Beautiful, we're flying. There's a positive rate and you tell me gear up. These are the throttles, and how the throttles work is like an accelerator on a car. This is the control column, and when you pull back, we go up, and when you push forward, the airplane will go down. Probably most people would not call pilots scientists, but on the other hand, you need a lot of math and science.
Now when we hit the ground, I pull this back.
Okay, I'll help you. All right, there's 50 feet. The airplane starts to flare automatically. Right there at touchdown, you come up, you can feel the brakes coming on. Altitudes are numbers, headings are numbers, airspeeds are numbers. So an airplane is really just a fun application of mathematics. Perfect. Are you sure you haven't done this before?
Consider the following. You, me, air, everything is made of molecules, little pieces of stuff. And when things like air molecules get moving, they can exert pressure. Here, take a look at the molecule machine of science. See the little balls? They're moving like moving air molecules. And they exert a pressure on this paper disc, see? Now, what would happen if I moved the paper disc up real fast? Well, take a look. See, the molecules spread apart. They expand. They want to exert a pressure in the direction they're going, along the tube. They don't exert as much pressure this way or this way. And that's Bernoulli's principle. Yeah. It's the same pressure you feel when you're riding your bike. Excuse me, I'm going to generate a little wind here in the lab. See? You feel wind on your face. You feel pressure. You don't feel as much pressure on the back of your head. Now, this pressure is called dynamic pressure, the pressure of moving air. So the same thing happens on an airplane wing. Suppose we had an airplane wing like the plastic airplane wing of science. See, as air goes over it, the air going under the bottom exerts a little pressure on the bottom. But the air going over the top doesn't exert as much pressure this way, this way, this way, or this way. So we get lift. See, lift, it's all done with molecules. See ya!
Here's an easy experiment you can try at home that shows you the difference between high and low air pressure. All you need is some string, tape, a straw, and 2 ping pong balls hung up like these. Take the straw and blow air between the balls. What do you think will happen? Okay, so you have your ping pong balls set up. What do you think's gonna happen now? You might think that the air going between the balls would push them apart. But when you try it, they get closer together. That's because the fast-moving air has lower sideways air pressure than slow-moving air. So the faster air going between the balls makes the pressure on them drop. Since the air on the outside of the balls has higher pressure, it moves the balls closer together. This is called the Bernoulli effect, named after the Swiss guy who discovered this principle of pressure. The Bernoulli effect is what makes birds, airplanes, and kites fly.
Switzerland is also known for chocolates, Swiss cheese, and cuckoo clocks.
Bernoulli. He was onto something, huh?
Northwest 7 heavy sail ready for departure. Northwest 7 heavy runway 16 left taxi position. What I do for a living is I'm an air traffic control specialist.
United 1421 heavy sail to ground, roger on the push-up boss ready taxi. Verify with information charter.
Northwest 7 heavy runway 16 left cleared for takeoff. The airplanes have to talk to us at all times. From the time they push back off the gate until they land again, they're talking to an air traffic controller.
American 1133 Shell Tower, 16 left, taxi to position, hold traffic pressure.
Our job involves science every day. Wind 20010, runway 16 right, clear to land. I decided to be an air traffic controller in the 6th grade, and I got fascinated in flight and just different scientific formulas. And then I found out that I had to know about clouds and precipitation, and science became my favorite subject in school. In fact, it was my best subject, science was. If you find out what you want to do at a young enough age, then you can strive for it when you get old, and anyone can achieve a goal if you strive for it and push for it hard enough.
Wright brothers, first to fly an airplane with an engine. Charles Lindbergh, first person to fly alone across the Atlantic. Amelia Earhart, first woman to pilot a plane across the Atlantic. What do these 3 have in common? Famous flyers, true stories, this week on the Johnny Lift Show.
This looks like an ordinary wing, doesn't it? Well, it is an ordinary wing, only it's really small. And scientists test wings, not in the wild, anything-can-happen world of the outdoors, but in here. This is a wind tunnel. A tunnel with wind! Remember when we were flying our plastic airplane of science? It didn't make any difference whether we were flying it in front of a fan or flying it with a toss. The wings lift the same way. See, planes take off and land toward the wind. That way, whether they're speeding up to take off or slowing down to land, there's already air moving over the wing. Not that bad. So airplanes can get big and complicated, and sometimes look a little weird. So we always want to make sure they fly the way we want them to. So it's easier, and I dare say a lot less expensive, to test wings and airplanes in here than it is to go just building one and seeing what happens. These big ones fly great, and they were all tested as models. Some people are afraid that airplanes can't fly. I guess because the air they fly through is invisible. Well, so is the air we breathe, for crying out loud. I mean, it's just air. Now, we humans have figured out ways to make pretty good wings. And they develop differences in air pressure. And differences in air pressure, that creates lift. Now, in order to get lift, you have to have the wing moving. You have to have the air moving. It's kind of like having your face in front of a fan, huh?
Or like when you're riding a bike. You feel the wind on your face, the pressure of moving air. That's what we call dynamic pressure. It's what makes airplanes fly. Anyway, a human on a bicycle is a very efficient machine. There's airplanes now that you actually get in and pedal for power.
This is the Gossamer Albatross. It was the first human-powered airplane to fly across the English Channel. It was pedal-powered by Brian Allen. Don't kid yourself. Pedaling hard and long enough to keep an airplane like this flying is no easy task.
Pay attention.
But wait, there's more. You also get a wing with an angle of attack and lift. Isn't that amazing?
Science! Check it out!
And I have made 250,000 of them with kids. We're gonna put a line here, right? Did you see how that happened?
Yeah.
We got that one all done. And there it is.
Air pressure. Wind. Lift. This is science.
We got all of them up in the air that we made, and they're flying. They're flying. They're flying.
Check it out. Science is cool.
Wings will maintain lift as long as they have an angle of attack. Look in here. Not bad, huh? Helicopter rotors work just like airplane wings. Instead of flying straight through the air, though, they also spin in a circle. They develop differences in air pressure, and that develops lift. They work great.
Helicopters have wings that spin. Here's how you can make your own helicopter. You'll need a piece of cardboard, like a cereal box, a pair of scissors, some tape, and a pencil. Anyway, here's what you do. Cut your helicopter rotor blades as science, like this, notch it in 4 places, here, 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 and here. Bend it at the end of the wing in opposite direction, tape it to your pencil, and you're ready to go. Take your helicopter and spin it. See? It flies. It works just like a real one.
Here's another type of helicopter. Cut a piece of paper like this, fold these 2 flaps down like this. Now, put a paper clip on the bottom and watch it fly.
Helicopters! Science!
The kites and planes and butterflies have things in common. One's the sky. They all can sail through the air, and birds
Now you know how birds, bats, butterflies, and airplanes fly. Basically, it's three things. 1, air has pressure. 2, to get things to fly, we want differences in air pressure. Now, those differences in air pressure come from Bernoulli's principle. You remember the Swiss guy? As molecules of air go this way, they don't exert as much pressure this way or this way. You remember Bernoulli's principle, the Swiss guy with the cheese. And 3, when you give a wing an angle of attack, then Bernoulli's principle comes in and makes low pressure on top and high pressure on the bottom, and that creates lift. Well, I got some serious angles of attack to develop. Gotta fly, Bill Nye, the science guy. See ya!
Produced in association with the National Science Foundation.